So in 3.3, using the addition rule, this is question 17. So remember, when it comes to the addition rule, we're still talking about probabilities. So remember the probability of an event E happening is the number of outcomes in event E. So that's our desired outcomes divided by the total outcomes in a sample space. So that would be our fraction that we probably have to change to a decimal. Now, the addition rule, we also are looking for this word or. So if we have the probability of A or B, one way to do it is it's going to be the probability of A plus the probability of B if they have nothing in common. This is what we mean by mutually exclusive, nothing in common. Then we have the probability of A or B. This is going to happen with, it's going to be the probability of A plus the probability of B, but you're going to subtract the overlap, what they have in common, the intersection. So it's got to be removed. This is what we refer to as not mutually exclusive, so they have an overlap. So if we look at question 17 here, the table shows the results of a survey that asked 1,071 adults from a certain country if they favor or oppose a tax to fund education. A person is selected at random, so we're going to complete these parts here. So in our table, we kind of pick up on the males that support and oppose and are just unsure. So we have 497 males participating. Females, 241 support, 308 oppose, 25 are unsure. So the 574 is the total females. And then the total support is 393. The total opposed is the 638. The total unsure was the 40. And then the entire sample space was the 1,071. So question A says, find the probability that a person opposed the tax or is female. So we have the probability of A. So the probability of A is opposed to tax. So those who oppose the tax, 638 opposed, and there's 1,071 in that sample. So 638, and there's 1,071 there. The probability of B is female. Well, there are 574 that are female out of the 1,071. But is there a female that also opposed the tax? So is there this probability of A and B? So is there a female that opposed? Such that there are 308 that are female that opposed out of that 1,071. So 308 out of this 1,071 were female that opposed. So we have to remove that out of the problem. So basically what we come up with then is 638 over this should be 1,071. 1,071. We're going to add in the 574 over the 1,071. But then we have to remove the 308 minus the 1,071. So since we really have I don't know where I get this 2 at, 1,071. So really all I got to do is we'll focus on the numerator since these are common denominators. So if we just go 638 and add in the 574 and then remove what's in common, subtract the 308, we're going to end up with 904 out of this 1071. So 1,071. So if I divide the 904 by 1071, that's going to give me then this 0.844. So 0.844. So 84.4% post-tax or are female. So if we look at part B, find the probability that a person supports the tax or is male. So I'll get my little eraser out here and clean up my little table here. So find the probability that a person supports the tax or is female. So the probability A, I'm going to say, is supports the tax. So we have 393 people support the tax. And there's 1,071 in that sample space. Male, we have the 497 are male out of this 1,071. But is there a male and supports the tax? So actually, let me try to clean that up a little bit. So write that a little bit better for us. So the probability B was male. That was 497 out of the 1071. But is there somebody who supports the tax and is male? So supports tax and is male. So notice how male that supports is 152. So 152 out of the 1,071 are male that support the tax. So we have to remove that out of the problem. So what we have then is this 393 over 1071. Keep getting that 2 there. Plus then this 497 over 1071. But then we're going to subtract the overlap, since these are not mutually exclusive, the 152 from the 1071. So if we just focus on the numerators, 393, add to that the 497, and then remove the 152 that are in common, that's going to leave me with just 738. So 738 out of this 1071 would be our probability. So if we divide that by the 1071, that's going to give us then 0.689. So 0.689 would be that part there. So that'll give us those. So notice how that word or makes us focus on the problem a little bit differently than our previous lesson. So hopefully you find those examples useful.